Hi, this is a demonstration of IOI-GASP Challenge 2 quantification evaluation web app. So this web application evaluates a gene isoform quantification and expression fold change estimate using long range. And for the interpretation of the evaluation matrix we are using, we have a comprehensive web page here to give you the demonstration how this evaluation matrix works, how they are calculated, and the illustration for you to get an understanding of these matrices. For the input and output, we have a definition here with all different scenario, what column what column means, and example data set here. We also have some example toy data for you to download and play with. We have multi-replicate simulation data under different conditions, and a single replicate simulated data quantified by multiple methods will give you an understanding how the method comparison works. And to get for this demonstration, we'll use the ECCB 2022 example datasets. This is H1-DE and H1-hESC. For the expression matrix, as for the input of our expression matrix, it looks like this. So the first column will be the transcript ID, and the next column is the transcript expression in TPM for different conditions. Here we have three H1-DE replicates and three H1-hESC replicates, and all these expressions are in TPM. So first we need to define what kind of input dataset we are using. Of course, we have multi-replicates under two conditions, and we have only a single method. We will evaluate the performance of talon on these two datasets, and here upload the quantification results as we just shown. It gives you some basic information of your input. So for example, number of lines, number of replicates, you can make sure it's correct. And then you need to upload the annotation you are using. I have already uploaded some existing annotation for you to use. For example, we can just simply use this one for our demonstration. Of course, we can, if you use your own custom annotation, you can choose your own GTF file and upload here. For the ground truth, because we are evaluating real data sets, we don't have any available ground truths. And we click submit. So first, it will give you some basic statistics of the overall performance. For example, resolution entropy, consistency measure, and reproducibility measure. So if you want to know more of this matrix, you can click here. This will show you how these matrices are calculated. So for resolution entropy, it will show what kind of resolution of your quantification method. For consistency measure and reproducibility measure, it will show you how your quantification how is the consistency of your quantification among different replicates. If different replicates give the same result, we will think the quantification of this transcript is very accurate. And we can also add some plots to show the quantification. For example, I will first show some basic information of your annotation. For example, distribution of isoform length. Click Add Plot. It will give you a histogram of the isoform lengths of your annotation you are using. And all this figure I will show, it will be fully interactable. And you can see the exact number here. Then I will show you the coefficient of variation versus the estimated abundance curve. So the coefficient of variation is pretty similar to standard deviation among different replicates. With lower coefficient of variation, that means you have lower variance of different replicates for that transcript. So with lower coefficient of variation, the transcript will be more accurate to be quantified. And as shown here, with higher estimated abundance, the coefficient of variation will be lower, and that means these transcripts are more accurate to be quantified. Because we have two conditions we're uploading, the first condition 1 is H1-DE, and the condition 2 is H1-hESC. You can also see the overall performance by looking at the area and the curve for these two curves. And with lower area and the curve, that means the coefficient of variation will be, the overall coefficient of variation will be lower, and that condition may be more easier to be quantified. We can also plot the consistency measure curve here. So it will show with higher consistency, and with higher consistency, that means the expression among different replicates for that transcript will be quite similar. That means this transcript will be more easier to be quantified. And also you can see the area and curve for these two conditions for the overall performance. And we can also see the resolution entropy for different conditions. And as we are using the same software for quantification, these two conditions will give pretty similar resolution entropy, showing the quantification software will give pretty same resolution with same resolution when quantifying these two conditions. We can also see how this performance matrix are correlated with different features. For example, we can see the statistics with different number of axons. This shows the number of the consistency measure, the resolution, the reproducibility measure, and the resolution entropy changes with different number of axons. You can see all the interpretation of these figures by check this link. And if you want to download these figures for further usage, you can choose either download one figure or download all figures. So here I choose download all figures. And it will give you a zip file containing all the figures you already generated. Okay, so here it shows you all the figures you have generated in both PDF, that's the vector image, and the PNG file, and the bitmap image. And that's basically my demonstration of this web application. And thank you for your attention.